All right, guys, so you guys have been working on DNA replication, a review from last class using the Amoeba Scissors video. I'm going to come around to you all in a pattern, and I'm going to make one of three markings on your paper. So if the answer is correct, I'll simply put a check mark next to that question. If you almost got it, but you need to add a little more to your response, or you're on the right track but need a little direction, I'll add a hyphen. And the third marking will be a question mark. So that'll mean that you need to retry your answer and go back and review that concept, okay? So I am going to be coming around to check for questions number 1, 2, and 3, okay? So make sure that you have questions 1, 2, and 3 on the front completed. I'm going to come around now. Good use of vocabulary, guys. Can you flip your paper over to the front, please? Try adding some vocabulary, some familiar vocabulary from like the sales cycle to your answer. Use of vocab. Good use of vocab. Let me flip your paper over. Alright guys, this time I'm coming around to check for the box with questions 2, 3, 4, 5, and 6. Make sure that you have calculated the number of deoxyribose in the picture, the nitrogenous bases, hydrogen bonds, as well as the phosphates. Be careful to label the 3 to 5 prime and 3 to 5 prime strands, okay? I will be coming around to check that. It looks like many of us were able to successfully label our DNA molecule. Now let's go over it together, guys. Let's look up here. So for question number 2, you all were to label the deoxyribonucleic. So now that we've gone over that, and many of you did label your DNA molecule correctly. So can someone tell me where the sugar is found on this DNA molecule? The orange hexagons, yes, the orange hexagons form a chain, a sugar chain. What is that sugar chain called? Polysaccharides, yes, polysaccharides. These are chains of carbons that form the outer or the backbones of our DNA molecule. In between these sugar molecules, there are these little green circles. What are those green circles that also make up the backbone? Amaria. Yeah, phosphate. So sugar and phosphate alternate on the outer sides of our DNA molecule. Now in the middle, we have what? What are in the middle, making up the rungs of our DNA molecule, Shannon? The bases, yes, the bases. So there are 4 bases in DNA. And class repeat or answer the question. So if we have adenine, the base adenine, A, it is going to pair with what?
T.
T, yes, T. And if we have the base pair G, guanine, it's going to pair with
C.
C, yes. So we have C and G, or G and C, and A and T, making up the rungs or the middle of our DNA molecule, okay? So if we have a phosphate group, a sugar, and a base, that is going to make one nucleotide. So our DNA molecules are repeating nucleotides that form together. There's 2 strands, so this is one side, reading it from 5' to 3'. And then our opposite side is going to be read in the opposite direction, from 3 to 5'. So while I was going around checking, some of us use a particular vocab word. What do we call reading our DNA strands from 5' to 3' to 3' to 5'? Denver.
Anti-parallel.
Anti-parallel is correct. So you know that parallel means side by side, and then the prefix anti means kind of like the opposite. So you're reading it from 5' to 3', and then 3' to 5', okay? What else do we have to label? Our hydrogen bonds. Where would our hydrogen bonds be found? Yeah, in between these bases. So these bases, they kind of link together like puzzle pieces, but they have strong hydrogen bonds, these little hyphens in the middle, holding those base pairs together. All right, so that